Welcome! Today, we are conducting a deep dive into Flysmart plus Takeoff performance computation. Specifically, we will be focusing on the critical operational protocols for both standard and downgraded runway condition codes, ensuring your performance data is as precise as your flight path. Every takeoff performance calculation in the Flysmart Plus environment hinges on a single critical variable derived from your runway condition report or NOTAM. That variable is the Runway Condition Code, or RWYCC. Identifying this code in the raw data is the essential first step in determining your computational path. Once you have the reported code, you face a binary decision. The RWYCC dictates your exact input sequence. If the reported code matches the contaminant, you follow Path A, the standard protocol. However, if the code is lower than expected for that surface, you must execute Path B, the downgraded protocol. In a standard scenario, the assigned RWYCC aligns perfectly with the expected code for the reported contaminant. For example, if you see dry snow and a code of 3, there is no indication of reduced friction. In this case, no manual override is required from the airport authority. When assessing standard performance, you rely solely on the runway condition data for the active runway. Simply input the specific contaminant type and its reported depth directly into the primary field, and let the system handle the baseline physics. This is a critical step for Path A. To instruct the application to use only the standard runway data, you must actively configure the secondary field. The RWYCC input field must be specifically selected as none. Failing to do this can lead to conflicting data points in your final calculation. Path B is triggered when braking action reports or runway observations indicate friction is lower than what the physical contaminant suggests. This is where the airport authority assigns a lower RWYCC than what is typically associated with the reported contaminant type. Consider this scenario. The NOTAM reports dry snow. Normally, that's a code of 3. But today, the authority reports a code of 2. This discrepancy is your signal that a downgraded protocol is mandatory for an accurate safety margin. To process a downgrade, we separate the inputs. First, enter the physical contaminant data. Input the dry snow and the specified depth directly into the RWYCC field. This tells the engine how much physical resistance the aircraft will encounter during the roll. Next, you must utilize the secondary input option to account for the friction loss. Access the RWYCC field and select the specific downgraded code reported. In our example, we would select 2 medium to poor. This ensures the braking calculation reflects the actual runway state. Why the 2 inputs? The Flysmart Plus calculation engine is designed to be highly sophisticated. It separates physical displacement from surface friction. By providing both data points, the engine can build a high-fidelity model of how your aircraft will behave from V1 to rotation. Think of it this way. The RWYCC and depth field calculates the physical drag and aquaplaning effects of the contaminant. The RWYCC override dictates the absolute lowest friction coefficient allowed for the braking calculation. Together, they cover the full spectrum of runway interaction. Whether you are under standard or downgraded protocols, the computation is not complete until every parameter is defined. Ensure all other required fields, from tow to flap settings, are accurately filled before hitting compute. Accuracy here is non-negotiable. For your convenience, this matrix summarizes the 2 paths. Remember, for standard, it's contaminant plus none. For downgraded, it's contaminant plus the specific reported code. This is your go-to guide for maintaining operational compliance in the cockpit. Precise inputs guarantee optimized performance. By letting the reported runway condition code dictate your path and separating drag from friction, you ensure absolute compliance with flight operations engineering protocols. Fly safe and fly smart.